My name is Campbell Mutert, and this is my video lab 1 for charge tape. The purpose of this lab was to observe interactions between charge tapes to determine the amount of excess charge present on a tape and build a computational model to visualize this. The results I got were that tape B was repulsed by tape A, indicating a like positive charge. The magnitude of the charge of the tape was 1.4 times 10 to the negative 8 coulombs. The electron deficiency for a piece of tape was 8.75 times 10 to the 10th, and there were 4.57 times 10 to the 6th atoms per electron on the piece of tape. Important physics concepts for this experiment are the momentum principle that says if there is no change in momentum, then the net force is zero. Coulomb's law says that the electric field for a point charge is the constant 1 over 4 pi epsilon naught, or K, times the charge over the distance from the source to the observed location squared in the r-hat direction. To find the electric force, multiply the electric field by the charge of the point charge. The gravitational force is mass times the gravitational constant. The field lines at the bottom show that opposite charges attract and that like charges repel. In this experiment, the system is tape B and the surrounding is tape A and the Earth. The length of the tape was 0.2 meters. The width was 0.02 meters. Its mass was 2 times 10 to the negative 4th kilograms. The constant K is 9 times 10 to the 9th newtons meter squared per coulomb squared. The gravitational constant is 9.81 meters per second squared. The length of an atom is 1 times 10 to the negative 10th, and the effective charge Q is 1.6 times 10 to the negative 19th. The tape was stationary when the distance was 0.03 meters, so here F net equals 0, Fe equals negative gravitational force, and the absolute of both was 0.00196 newtons. The assumptions for this experiment were that the strip of tape is treated as a point charge, and that each strip had approximately equal amounts of charge with even distributions, and also that air resistance and loss of charge are negligible. Our observations for this were that tape B was attracted to the neutral table, it was attracted to a negatively charged pin which indicated a positive charge, and it was repelled by another piece of charged tape, so the two pieces of tape had like charges. And then we observed that tape B moved when tape A was 0.03 meters away. I input all of the constants from the last few slides into the code. I calculated the gravitational force and made the electric force equal to its magnitude. I used the rearranged electric force equation from the intro slide to find Q. The electron count on the tape was the charge of the tape over the charge of a single electron. The atom count was the surface area of the tape divided by the area of one atom. I used these to find the number of atoms per electron. The magnitude of charge on one piece of tape was 1.4 times 10 to the negative 8 coulombs. Since the pin and our skim have a slight negative charge, the charge was positive because the tape was attracted to those items. The electron deficiency per tape was 8.75 times 10 to the 10th, which also indicates a net positive charge. Finally, there were 4.57 times 10 to the 6th atoms per electron on one piece of tape. I found that the computational results aligned with the experimental observations, as both indicated positively charged tapes. The sources of error for this experiment were possible incorrect separation distance, estimations of atoms and weights, loss of charge due to handling, and unequal charges of tapes. To answer the what-if question, if the electrons were positively charged and protons were negatively charged, there would be no difference in the observed results. The negatively charged pin would have a positive charge, meaning that the tapes would be negatively charged with the same magnitude, and they would still be repulsive. The reason that we should not handle the tapes is because when the charged tapes come into contact with our hands, the electrons would be transferred to the tape and it would lose or decrease its positive charge.